Hello everyone and welcome to your explanation for Worksheet 3A, and this is in week 5 of the college trig class here at Overland High School. So on this worksheet, what we're going to be doing is we're going to be talking about the graphs for a bunch of the different trig functions and what they look like. I think a graphing calculator is extremely helpful when you're doing this. So if you have access to one, make sure you're using it. If you don't have one, you really want one, come see me and I can sort you out with that. So first of all, on this first section, the first 6 problems on worksheet A, it says, what are the x-intercepts for the graphs of each function over the interval -2 pi to +2 pi? So a trip around a unit circle is 2 pi. So basically this is going to go around the unit circle in the counterclockwise direction, which is the positive direction, once. And then it's going to go in the opposite direction, which is -2 pi, once. So we're going to see a full cycle going to the right and to the left in positive and negative directions. So if we look at cosine of x, number 1, cosine of x is one you're going to want to memorize because it comes up so often. Cosine of x starts at 1, and remember these cycle in between 1 and -1 because the radius of a unit circle is 1. That's why that happens. So anyways, it starts off at 1 and then it goes down, and the bottom of the trough is at pi, and then it cycles back up to 2 pi. So it does a complete period is what it's called, a full wave within 2 pi. So to the right of the y-axis, it goes down, it goes up, and then it gets to the same starting point. So it does the same thing on the left. It goes down, then goes back up. And so this is what we have. So now we have to figure out, are the x-intercepts. Well, what's exactly in between 0 and pi? Well, that would be half a pi. So that's how I got that one. What's exactly in between a full pi and 2 pi? Well, that'd be like 1.5 pi's, or 3 pi over 2. And then same thing going backwards, we have -half a pi and then -1.5 pi. And so that's how I came up with all of the x-intercepts. Okay, let's look at number 2. This is sine of x. Once again, this is going to be one you want to memorize because we're going to do a lot with this throughout this chapter. Sine of x isn't that different from cosine of x, except that it's shifted to the right or left, however you want to think about it, about ½ a pi. So instead of starting at 1, sine of x always starts at 0 and then goes up. Now we can manipulate that by adding negatives and stuff like that, but just your regular sine of x graph, which this is what this is, starts in the middle, goes up and hits its peak in between half a pi, and then goes back down, crosses at pi. The bottom is at 1.5 pi, and then it completes its full cycle at 2 pi. So it's going to cross 3 times. It crosses 0, pi, and 2 pi, and then on the left it crosses at -pi and -2 pi. So these are your most standard graphs. There's no manipulation to these. There's no modifications, anything like that. And so the rest of the section, you're just doing the other trig functions. We're doing tangents, cotangent, secant, and cosecant. Those graphs get a little bit weird. And those are ones you really don't need to memorize as much because we don't use them as often. But definitely cosine and sine you want to remember. All right. Let's look at number 7. It says, for which values of x in between -2 pi and +2 pi again are the following not defined? So what we're looking for here are vertical asymptotes. Sometimes when you graph these on a graphing calculator, they'll actually put a vertical line at these spots, and it makes it really easy to tell where they are. But if not, it's just where's the graph not crossing. So I did number 7 and 8 for you. So for 7, it's a secant graph. Well, secant has a bunch of parabolas, and they're in between these. I put them in as like a blue dashed line here, and they're vertical asymptotes. So they'll get really, really close to these lines, but they'll never cross them. So if you're looking at the graph, the asymptotes are going to be at ½ a pi and 1.5 pi on the positive side, and then -½ pi, -1.5 pi on the left side. And that's it. The other weird thing about secant is it never goes in between 1 and -1. So it never goes within that region. There's it basically a horizontal asymptote there, basically. But on this one, they're asking for vertical asymptotes. All right, let's look at number 8. So number 8 is really, really similar to a tangents graph, except it shifted a little bit, and the S-curves, I guess you call them, these red lines, they're going the opposite direction. So they're going from the top on the left side to the bottom on the right side. So anyways, we graph these, and we get an asymptote at the y-axis, so at 0, pi, 2 pi, and then negative pi, negative 2 pi. On your graphs, just be very, very mindful of your labeling the axis, and then just these S-curves, try and make sure they're getting really close to your asymptotes and they're not crossing them, and try and keep it as neat as possible. Okay, and then the only other one I'm going to do for you today is going to be number 13. So number 13 says, without looking at your notes or using a graphing calculator, graph the following functions. So this is exactly what I did up top, but now it's on a bit of graph paper, so it should be a little bit more precise. Once again, I think sine is definitely going to be one you want to know. So for this, sine always starts in the middle. We know it's going to do a full cycle between 0 and 2 pi, so you can put that end dot at 2 pi. And then we know it has to cross in between, right? Exactly in between, so we're going to put a dot at pi. And then I do a trough or a peak in between 0 and pi, and then a trough in between pi and 2 pi. And then I just kind of connect the dots, and I get the curve on the right side. I continue this motion on the left side, so I label negative 2 pi, negative pi, put the high peak and then the low trough, and then just connect them with the line. And this is what you get. Be very, very mindful when they give you a piece of graph paper that you're scaling it well. I said, like, on the horizontal axis, on the x-axis, I put pi and 2 pi spread out so that 2 pi was right on the edge. And that's just so that the graph looks nice and stretched out. Same thing with 1 and negative 1. I put 1 almost at the top and negative 1 at the bottom, so I'm counting by quarters, really. But this is just to give me a nice looking graph. You could compact this whole thing so it's like in just a couple of these squares, but it doesn't give it as nice of a look, I think. So be mindful of that. All right, so that is it for worksheet 3A. Should you have any questions, feel free to email me. There is lots of Khan Academy videos on this, and help online if you're just not getting the graphs. But they're pretty straightforward, and if you have a graphing calculator, it makes it really, really easy on these. So let me know if you have any questions, and good luck with this.